Hi everyone. In this video we are going to solve another example from the ambiguous case, and here in this example we have taken the angle B as an obtuse angle greater than 90 degree. From the theory video we have seen that when B is an obtuse angle, solution is possible only when the side length B is greater than side length C. And I have noted it up here that when B is greater than C, the side length B is greater than side length C, we have one solution possible, and of course it will be an obtuse triangle. But when B is less than or equal to C, then no solution is possible. So in an example, the first thing you want to do is you want to check the data that has been provided. If the value of B is greater than the value of C, then only a solution is possible. Otherwise your straight answer would be there is no solution. We cannot even draw the triangle. Now in this example, as you can see, I have provided that B is equal to 9 cm, C is equal to 3 times square root of 3 cm, and the angle B is 120 degree, which is of course an obtuse angle. Here as you can see, side length B, which is 9 cm, is clearly greater than the side length C, which is 3 times square root of 3 cm. So in this case we have a solution, and that solution will be an obtuse triangle. Now we have to find out the three other attributes, right? The side length A, the angle A, and angle C. Before seeing the solution, you can pause the video and give it a try yourself, and after that of course you can check my solution. So I'm going to solve the problem here. Let me first draw the triangle and see how it might look like. Here I have drawn a probable triangle where the angle B is 120 degree. The side length B is noted as 9 cm and the side length C is noted as 3 times square root of 3 cm. Now we have to find out the three other attributes, and what are those? Well, the side length A, so we have to find out the value of side length A, and then of course the angle A and the angle C. Those are the three other attributes that we have to solve for. Alright, now we can probably use the sine law. That might be the easiest one. So let's try to use the sine law here to find the angles first. So what is the sine law? Well, we know that it is A over sine A is equal to B over sine B, which is equal to C over sine C. And also we know that that is equal to 2 times the circumradius. And in this particular example, we really don't have to do anything with the circumradius, but I just noted it so that you know the complete sine law. Now if we take the second and the third ratios, so there we see B over sine B is equal to C over sine C. Now why am I taking that one? Well, because the side length B, the side length C, and the angle B, they all have been provided. So the only unknown there is the angle C. So we can easily find the angle C. So let's use this part of the sine law here. So what is B? B is actually 9. So that would be 9 over sine of B angle. So that would be sine of 120 degree is equal to C. What is C? C is actually 3 times square root of 3 over sine of C, and we don't know what is the C angle. That's what we are trying to calculate here. So from here, can we write it like this, that 9 over sine of 120 degree can be written as sine of 60 degree is equal to 3 times square root of 3 over sine of C. And from here we can say that sine of C will be equal to 3 times square root of 3 over 9, and all of that times sine of 60 degree, which is equal to 3 times square root of 3 over 9 times sine of 60 degree, which is square root of 3 over 2. And if we simplify this quantity, this is actually 1/2, because you see the numerators totally become 9, and then we have a 9 in the denominator, so they will cancel out each other, and we are going to be left with just 1/2. And this can be written as sine of 30 degree, and also it can be written as sine of 150 degree. Now in this case, which one we should take? Well, because we know that angle B is already an obtuse angle, so we really cannot have any other obtuse angle for this triangle. So the other two angles definitely have to be acute angles. So in this case our solution is 30 degree. That means angle C will be 30 degree. We really cannot go for the 150 degree, then it will violate the property of the triangle. So in this case we are going to take 30 degree as the solution for the angle C. So here we can say then angle C is equal to 30 degree. Angle B has already been provided, and we have already figured out the angle C, so we can easily calculate the angle A. Angle A would be equal to 180 degree minus the sum of the two other angles. Angle B is 120 degree and angle C is 30 degree, so that will be equal to 180 degree minus 150 degree, and that is equal to 30 degree again. So here we see that A is also equal to 30 degree. That means this is actually an isosceles triangle, which is okay. No problem. So angle A is 30 degree and angle C is 30 degree. So let me make a note of that in the diagram here. Now the only other remaining attribute we have to find out is the side length A. So now I'm going to use the first two ratios from the sine law, and there we have A over sine A equals B over sine B. So we can write it as A over sine of 30 degree because we know the angle A is 30 degree. So A over sine of 30 degree is equal to B over sine B. Now here B is actually 9 centimeters. So I'm writing B over sine of 120 degree, and from here we can say then A is equal to 9 over sine of 120 degree, which is actually sine of 60 degree times sine of 30 degree, and this is equal to 9 over, what is sine of 60 degree? Well, we know it is square root of 3 over 2, and sine of 30 degree is actually 1/2, and if we simplify this, this is going to become 9 over square root of 3 times 2 times 1/2, and then here you see this 2 and this 2, they will cancel out each other, and then square root of 3 will convert this into 3 times square root of 3. So essentially A is equal to 3 times square root of 3, and the unit will be centimeter. Now if you are thinking that as soon as we found the angles A and angle C, then we should have realized that the side length A will be same as side length C because it is an isosceles triangle. So obviously side length A should have been equal to the side length C, which is 3 times square root of 3 centimeter. I really didn't need to do the derivation, but still I wanted to do it so that I can show you that even if you do the derivation using the sine law, you are going to arrive at the same value. So we were supposed to find out the three other attributes, which are the side length A, the angle A, and angle C, and we have already completed our calculation. We have found the value of side length A, which turned out to be 3 times square root of 3 centimeter, and angle A as well as angle C, they are 30 degree each. This brings us to the end of this video. In the next video, we will be taking another example from the ambiguous case. I hope everything made sense here. Thank you for watching. See you in the next video.